Welcome back. We're going to talk a little bit about measurement. Our learning target today is to identify basic SI units of mass, volume, distance, temperature, and time. But before we get started, you're going to need a full sheet of paper, and we're going to make a foldable as we're going through these notes. To set up your foldable, you'll take a plain piece of paper and fold two flaps, one from the left and one from the right, into the center of the page. It might be helpful to draw a line at the center or to even fold, but you don't have to. Now that you have your folds, we're going to make 4 cuts, 2 on each flap. This will give you 6 tabs that we can use to write some information. Now that we have our flaps, we're going to label the outsides. Do it just like the picture on the right. The left side flaps will go length, then mass, then time, and on the right side we'll do volume, then weight, then temperature. In just a minute, I'll help you fill out the inside and the underneath part of the flap. So as we go through this, we're going to write definitions and examples. Under the flap in this area, we put definitions. On the back side of the flap, we put examples. Definition, example. Definitions in this area, examples on the back side of each flap. All right, length is our first unit of measurement or type of measurement we're going to talk about. The definition of length is really the distance between 2 points. So when we're talking about distance, we're talking about length. The unit that we're going to use for that is usually going to be meters or centimeters. Those are our standard units. Sometimes we'll use millimeters if it's really small. Sometimes we might use kilometers. In science, generally though, meters and centimeters are what we're going to use. So an example, the length of my pencil is blank centimeters. About how many centimeters do you think your pencil is? If you think it's about 15 centimeters, you're probably right. It kind of depends on your pencil. Just for reference, your foldable should look just like this. All right, the next measurement you need to know about and understand is mass. Mass is how much matter, or the quantity of matter, in an object. This number doesn't change no matter where you go. So like on Earth compared to the moon or Jupiter or whatever, mass is always going to be the same. Our units we use for mass are kilograms or grams. You might also see micrograms if you're talking really, really small, centigrams, things like that. 1 kilogram is equal to about 2.2 pounds. So if you weighed 120 pounds on Earth, you'd weigh 54 kilograms. So time is a measurement of a period during which an action or a process happens or any condition continues. The units we use are seconds or minutes, or of course hours, days, weeks, months, things like that. But in science, seconds and minutes are our standard units. So an example of this class is 55 minutes long. That translates to 3,300 seconds. The next measurement you need to understand is volume. Volume is basically a measurement of how much space something occupies. It's 3-dimensional space. The units are usually cubic units, but they can also be something like liters or milliliters. So you might see meters cubed or centimeters cubed. You get that because you're taking, for example, a cube, a box, and multiplying the length of the 3 sides times each other. If the unit is in centimeters, it'll be centimeters times centimeters times centimeters. Anytime you multiply something times itself 3 times, it's that number cubed. Well, it's the same with a unit. Something else you should know that's interesting is milliliters are equal to cubic centimeters. So 1 milliliter and 1 cubic centimeter are the exact same measurement. They're just 2 different ways to write the same thing. Next we have the measurement of weight. Weight's kind of interesting because a lot of times we talk about it like it's the same thing as mass, and on Earth it generally is, but if you leave Earth, that changes. Weight is the force that gravity pulls on matter. So where mass stays the same no matter where you are, weight doesn't. Weight is dependent on the gravity. So for example, on Earth, where we have 6 times more gravity than we do on the moon, we're going to weigh a lot more on Earth than we do on the moon. Now the SI unit we're going to talk about is newtons, but most of us are used to pounds. But the example we have here, because there is more gravity on Earth than on the moon, I weigh 1/6 on the moon what I'd weigh on Earth. Because remember, the Earth is 6 times bigger than the moon. So if you look at our picture over here, the mass on Earth and on the moon are the same, 120 kilograms. But because gravity is different, the weight is different. So when you look here at the weight of this astronaut on Earth, it's 1,200 newtons, where on the moon, that same guy weighs 200 newtons because the gravity is so much less. Our next measurement, and our last one we're going to talk about, is temperature. In science, we talk about temperature in terms of degrees Celsius or Kelvin. Most of us that we're most familiar with degrees Fahrenheit. But temperature really is just how hot something is. We always use it to measure heat. So if we're familiar with Fahrenheit, we know that water freezes at 32 degrees Fahrenheit. So when we know it's 32 degrees Fahrenheit, it's cold outside. That means it's 0 degrees Celsius. If it is boiling, if water were to boil, it'd boil at 212 degrees Fahrenheit. It boils at 100 degrees Celsius. Now the difference between Celsius and Kelvin, 1 Kelvin degree and 1 Celsius degree are the same. That change in degrees. But 1 degree Celsius is not the same as the temperature 1 Kelvin. That's kind of a confusing concept, but what you really need to understand is that 273 kelvins is 0 degrees Celsius. So water freezes at 273 Kelvin or 0 Celsius. Also, something called absolute zero is where all molecules stop moving. Also a weird concept, but it's kind of a theoretical temperature. To get from Kelvin to Celsius, it's just addition and subtraction when you're converting between the two. Just have to remember that number 273. All right, your entire foldable should now be completely filled out, and you can attach it to a right side page in your interactive science notebook. Make sure that you can summarize the different types of measurements and give examples for each, because that's going to be something you have to do soon.